In this video, we're going to investigate John Dalton's ideas about matter. John Dalton was a scientist that worked in the early 1800s. He built on a lot of work from scientists before him, but his first ideas of matter probably came about from experiments similar to the experiments we may have done in class with the air that we compressed in the syringes. And so those kind of experiments might have given him some first ideas about matter. In particular, he was a proponent of a particle model of matter. But those were not the experiments that really confirmed in his mind or others that the particle model of matter was a particularly good model. Instead, his ideas of a particle that really cemented a particle model of matter in his head, again, the idea that matter is made up of small particles, was an experiment that had a little bit more to do with putting particles together or putting matter together, mixing matter. In fact, the technical word we use is reacting. And so as an example, I'm going to talk about the reaction or the combining of oxygen and hydrogen, which most of you know is when we combine them in just the right way, when we react them, they combine to form water. Now, you might not be surprised to find out that if we react 16 grams of oxygen and 2 grams of hydrogen, that we get 18 grams of water. And nobody would have been surprised about that. People who had a continuous model of matter rather than a particle model of matter would have predicted that too. You got a cup of oxygen, 16 grams worth, a cup of hydrogen with 2 grams of hydrogen in it, you mix them together, of course you're going to get 18. If you had a continuous view of matter, that it was indivisible or infinitely divisible, then there wouldn't be any reason you couldn't react all of whatever you wanted. And you might in fact predict that if we do a different combination, like 32 grams of oxygen, and mix those together in the right way, again we call that reacting, that we would get 34 grams of water. Well, that wasn't what Dalton predicted. Dalton actually predicted that we would get 18 grams of water. Now you might wonder why he might have predicted that. Well, what he noticed was that oxygen and hydrogen, in this example at least, react in a 16 to 2, or really what we call an 8 to 1 ratio. And so he expected that having a particle view of matter, that's the same thing that would happen here. And so when he reacted them, he found exactly that they reacted in a 8 to 1 ratio. So instead of getting 34 grams of water, well, what he found we got is 18 grams of water also. And then that left us with 16 grams of oxygen left over. Stuff that never reacted. And he felt it didn't react because there was no way to put that additional oxygen together with the hydrogen. Because there were just certain size pieces of hydrogen, and once those were taken up, there was no more. When Dalton looked at this, say, an example like this, the next situation, well, again, he expected that 8 to 1, and that's exactly what he saw. We get 18 grams of water. But again, here we have some extra. In this case, we have 2 grams extra of hydrogen. Now, take a look at this one. What do you think will happen here if we react 32 grams of oxygen with 4 grams of hydrogen? Did you predict 18 grams of water? If you did, you're probably following patterns rather than understanding the concept here. We can only react water, oxygen and hydrogen in 8 to 1 ratio, but that's exactly what we have here. And so we're going to get 36 grams of water with nothing left over. 0 left over. Nothing at all. Well, For Dalton, that was confirmation that matter was made of small particles. Now let's take a look at what someone who didn't think matter was made of small particles, but was rather continuous, what they might have thought about. They might have thought if we were in the middle of doing an experiment where we were putting hydrogen and oxygen together, they might have felt, well, we can mix just as much hydrogen as we want with as much water, and we'll just get as much hydrogen with oxygen, and we'll just get water. It might be a little bit, to make an analogy, a little bit like mixing as much Kool-Aid as you want. You can mix a little bit of Kool-Aid with the water, or a little bit more if you want, or a little bit more. You still have Kool-Aid. It's just, I guess, different sweetnesses or different thicknesses or whatever, but you still have Kool-Aid no matter how much water and how much Kool-Aid you mix. So the people who felt matter was continuous would have predicted this. The results that Dalton got, which of course I showed you on the previous screen, contradicts that. The results we got says, no, you can't just get as much as you want. You can only get however much is capable of getting, such that you maintain an 8-to-1 ratio of oxygen to hydrogen in terms of mass. Now, here's a more visual picture of how Dalton and other particle model of matter thinkers would have looked at this. They would have said, well, here's some particles of hydrogen, and here's some particles of oxygen. And by the way, at that time, there was some reasonably good sense of their mass. And let's say we take them out of their boxes and we put them together in another box that will allow them to mix together. Okay, so now they're in another box that they can mix together. So they mix together and they react. Well, water is water, right? So it's a certain combination of hydrogen and oxygen. And there's no way to get sort of anything but 18 as long as you have a particle view of matter. You can't divide a particle, and so you can't get a half of you can't get a sort of a total mass of 17.1 or 16.35 or something like that. Water is one of those with two particles, and that gives it that particular 8-to-1 ratio of mass, 16 to 2 or 8 to 1. That gives it a particular mass that we see in the data table below. I'm just going to finish bringing these guys over here, and what we see is in this example, we may have put a whole bunch of oxygen in, but it doesn't matter. We can only react enough to keep that 8-to-1 ratio. By the way, if you ever wonder why oxygen was called, or excuse me, water was called H2O and not sort of H1O8, it's because the numbers there don't refer to the mass, but rather the number of particles. So H2 and then an O. All right, so this led Dalton to be very confident that matter was made of small particles. And so he formulated his atomic model of matter. And he laid it out as such. His model was the set of ideas that allows us to understand the nature of matter. All matter is composed of small particles called atoms. Atoms are the smallest unit of matter. In other words, we can't have a smaller piece of matter than an atom. Atoms cannot be divided or split or broken apart. All atoms are of the same element are identical. Different elements have different atoms. And this piece here is really what set Dalton, this piece here, was what set Dalton apart from Democritus and the people that came for 2,000 years before him, who may have also felt that matter was made of small particles. But they didn't have the idea that each element had its own atom, and the atoms might be a little bit different from one element to another. Lastly, he said that atoms can combine, connect, rearrange with other atoms to make new substances. For example, carbon and oxygen combine to form carbon dioxide. Well, that is John Dalton's atomic model of matter, and more importantly, the evidence that he used to come up with that model of matter. As we'll see in the future, that was just a first step in the development of our current atomic model of matter.